This is the facts concept module 2 continuation of module 1. Module 1 related to the basic advantages of fact controllers and basic types of fact controllers and control parameters of both active and reactive. And coming to the module 2, the syllabus for module 2 is concept of voltage source converter, single bridge converter, and square wave voltage harmonics for this particular single phase bridge converter, and comes into the three phase full wave bridge converter and three phase current source converter, and comparison of current source converter with voltage source converter comes into this unit 2 or module. See, the basic concept of the voltage source converter, it is nothing but a conventional thyristor device, only turn on control. Generally, thyristors if you are using, it is only turn on control is possible. Go for the diodes. So diodes, both on state and off state both are not controlled. And coming to the devices like GTO and IGBT and MTO or IGCT, these are similar devices control the capability of turn on as well as turn off. So that's why it is called turn off devices. Thyristor is called as turn on devices, only capable to control the on state. So GTO, IGBT, MTO, IGCT, these are the devices can control both on state and off state. So converters applicable to the fact controllers would be always self-commutating. Always it is required self-commutating. Actually, there are two basic categories of self-commutating converters here. So that is current source converter and voltage source converters. So actually, current source converter, you see, current source converters in which the direct current is always one polarity, and power reversal all takes place with the reversal of DC voltage. When coming to these voltage source converters always the voltage having one polarity, and power reversal will takes place through reversal of DC current. That means voltage source current will be in both positive and negative, and current source converter voltage both positive and negative voltages are available. So conventional thyristor based converter being without turn on capability can only be current source converters, whereas turn off devices based converter can be of either type. That means thyristors is always used to uh, current source converter. Whether if you use turn off devices like GTO, the GTO consist bridges always used for both the current source converters as well as the voltage source converters. So that is the advantage of some turn off devices like GTO, IGBT, IGCT. What I have discussed in the previous slide, all are turn off devices. See, these turn off devices are capable to used like a current source converter as well as voltage source converter. But if you use a thyristors, it is only used for the current source converters. So these are the some limitations by using thyristor based converter. So these are the one basic concept of the voltage source converter. Based on the advantages, so we are mostly prefer the voltage source converters. You can clearly see the representation of valve of the converter. So it is always the parallel with the turn off devices, anti-parallel with the diode. So these are the valve for source converter. Mostly it is a voltage source converter. So how the voltage source converter can be represented? You clearly observe that. So this is the representation of voltage source converter. The basic representation is turn off device is anti-parallel with the diode. We are given some DC input. Okay, we are putting a large capacitance here. So to sustain the DC voltage. So this converter can convert this DC power into AC power. So uh, previously we discussed in voltage source converter, voltage having one polarity and current can be in both polarities. That means current can be transferred from DC to AC as well as the AC to DC. So that's why positive current and negative current. The power reversal will happen through current reversal. So this is the concept of voltage source converter. Here this is representing the DC voltage, DC current and active DC power. After conversion you will receive the AC side active and reactive AC powers. This is the voltage of AC voltage, that is VA. So this is the basic concept of the voltage source converter. You can clearly see that this is single valve operation. In this single valve operation, the large capacitor always placed in the DC side to maintain the DC voltage. So this is constant voltage VD. The polarity is constant. You can observe the direction of the current. You can give the both the directions. That means the current can be transferred from DC to AC side as well as the AC to DC side. So this is a single valve operation. You clearly observe that this is a single turn off device is connected with one diode with anti-parallel. So this is the basic arrangement. And, through this the valve can be operated. So you can next come for the single phase full wave bridge converter. So full wave bridge converter always consisting of 4 valves, each valve consisting of a turn off device anti-parallel with the thyristor, anti-parallel with the diode. Okay, so once the operation, so you can clearly observe that you can represent it is a valve 1 and valve 2, this is valve 2 and this is valve 3 and valve 4. Based on the operation we can give the valve numbers. So previously you can see that this is a constant capacitance. Then this is a transformer at the AC side to enhance the voltage or reduce the voltage based on our requirement. So this is a basic arrangement of single phase full wave circuit with a 4 valves. So each valve consisting of anti-parallel diode along with the turn off device, example is GTO. Okay. So once you go for this operation, so initially the output voltage, the magnitude is VD when 1 and 2 is on condition. So previously I told that based on the operation you can give the valve numbers. So during positive half cycle, this 1 and 2 on, you will receive the plus VD voltage. In negative half cycle you will get the 3 and 4 at on condition. This is representing some firing angle theta. So these are the AC currents. So if you consider rectifier action is positive, automatically the inverter action comes into the negative. Otherwise, if you consider the rectifier action is negative, the inverter action is positive. Like that you decide. If the 1 and 2 operation means, so this gives a negative means automatically when diode operates, it comes into the positive. And after diode, after firing angle, 3 and 4 will be at on condition. So the time period here represented is T1, T2 and T2, T3. So these are the intervals from T1, T2, 1 and 2 at on condition and T2, T3. So current is reversed through diodes, that is diode 1 and 2. Then it comes to the thyristors, turn off devices 3 and 4 from on condition. Then the current reversal will happen in the anti-parallel diodes, so that is 3 and 4. It's like that you can represent the AC current. Once comes to the DC current, DC current, the rectifier action always represented. So you can from here also you can say that once the rectifier is act means the power is flow from the AC to DC. So through diodes you can achieve the rectifier action. Through GTOs, that is turn off devices, you will get the inverter action. The valve is at on condition means that is a switch voltage is 0. The valve is off condition means you can clearly observe from the above figure. Here the valve is at on, 1 and 2 is on. So switch 1 is on means short circuit, automatically voltage will be 0. Switch off, here switch 1 is off, automatically the voltage will be appear across the switch. So these are the fundamental operations. So you can check the firing angle between the always VAB lags by theta, phasor relationship between the current and voltage. So simply in tabular form, we can represent this 4 operation modes in one cycle. That is the device 1 and 2 on and 3 and 4 is off. That is VAB is positive and current flow is negative, and conducting devices is turn off devices 1 and 2, and the operation is inverter operation. Same thing will be current flow is positive means through conducting devices 1 dash 2 dash. This is rectifier action. Once the 1 and 2 is on and 3 and 4 is on, the VAB is negative as well as current flow is also positive. That means conducting devices is 3 and 4. This is inverter action. Instead of 3 and 4, 3 dash 4 dash is active. Both the VAB and current flow are negative. Automatically comes into the rectifier action. We can represent the above thing in the 4 operation modes in the one cycle in a tabular form. This is a single phase converter operation in the tabular form. Okay. Next, coming to this square wave voltage harmonics. So AC voltage with peak voltage, that is VAB, is always represented square root of 1 by p integral of minus pi by 2 to plus pi by 2 v square d dwt. This is entirely equal to Vd. So this is the representation of AC voltage. Then you give the fundamental and individual harmonics equation. That means V is equal to 4 by phi to Vd is nothing but a DC voltage. Then cos omega t minus 1 by 3 cos 3 omega t plus 1 by 5 cos 5 omega t, like that it is so on. That means if you represent it in with n, Vn is equal to 4 by pi Vd into, so 1 by 3, 1 by 5, 1 by 7 can be represented as 1 by n cos n omega t. For n equal to value, always you here you see here 1, 3, 5, 7, that you can represent here. So then we can simplify as RMS value given as Vn is equal to 1 by n 2 into root 2 by pi Vd. So then the RMS fundamental components of the square wave is represented here with V1 2 root 2 by pi Vd, that is 0.9 into Vd. So this is square wave voltage harmonics for a single phase bridge. From here, then we move for the 3-phase full wave bridge rectifier. So 3-phase full wave bridge rectifier, you clearly observe that it consisting of 6 valves. Okay, each valve representing with GTO, that turn off device, anti-parallel with the diode. Like that, we are having 6 valves. Okay, and same the capacitance, total capacitance can be divided into equal by 2. That's why it is given plus Vd by 2 and minus Vd by 2. This midpoint is considered as a neutral. And the total capacitance is equally divided. So that's why you will get the total voltage here, that is DC voltage is Vd. Based on the, these are the 3 phases you included. For phase 1 is connected in between the valve 1 and 4, and phase B is connected in between the valve 3, 6, and phase C is connected in between the valve 5, 6. These are the 3 phases, AC phases are connected. Based on the operations, we can given the valve number. So it is not mandatory. As per operation also we can give this like 1, 2, 3, 4, 5, 6, like that. Accordingly you can change the operation modes. You see this is a phase 2 DC midpoint voltage. So the magnitude always Vd by 2. So here for phase A, positive side voltage is from the valve 1 and negative side voltage is valve 4. You see previous figure. Here 1 and 4 is connected to A phase. 3 and 6 is connected to B. And 5 and 2 is connected like that. We can represent VA, VB, VC. 1, 3, 5 is caused to generate the positive of 4, 6, 2 is caused to generate the negative. Then you can samely subtraction or addition like that. You can clearly observe that VA minus VB, that is VAB is nothing but VA minus VB. So if you are confused, write straight lines here based on this. Then you can clearly observe that here is a positive thing is there, minus of VB, that means this is plus, so both can be added. If 1 and 2 operated, both can be added. Here 1 and 3 operated, both are in anti, that's why it comes to 0. Here negative side 4 minus 3, 4 minus VB, that means both are in negative only, that's why negative side, if 3 4 and operates, you will get the negative side. So 4 and 6 operates, both are cancelled. Same thing will be repeated. 1 and 6 operate positive, 3 and 4 operates negative peak, and 1 3 operates, both are cancelled, and 4 and 6 operates, both are cancelled. Like that you can represent the VAB. Accordingly you can write VBC and VC. Based on these three waveforms, we can achieve the VBC as well as VCA. Simply you can cancel it. So from that we can represent the AC current, that is IA. You can clearly observe the time period from T1 to T2, always with the diode. Then it comes to move into the turn off device 1 from T2 to T3. When the reversal, current will reversal, automatically one reversal means GTO can be changed to thyristor. Here after firing angle it comes into the 4. Like that you can represent the phase current. So these are the neutral current with a magnitude of VD by 6. So once you write VAN, same concept. For phase to neutral voltage means VA minus VN. Here the previous slide VA is there, here VN is there. Sometimes it is added, sometimes it is different. Like this VAN. Okay, so this is another thing is valve voltage. Simply the previous concept we am explaining in the single phase full wave converter. If the valve is at on condition, so short circuit, the voltage across the valve is 0. The valve is a off condition, automatically the voltage is appeared across the switch. That is the simple representation. You clearly see that from here one is operating, so short circuit 0. Here one is not operating, that's why you will get some valve voltage VT. So this is simple operation, and accordingly you will write some currents, that is DC current from phase A and DC current from phase B and DC current from phase 3. These are the currents representation. You can clearly observe from this figure. I'm always say that rectifier action is given as a positive thing. Rectifier action is fulfilled through diodes only. So that's why it is comes 1 dash 4 dash 1 dash 4 dash. This is related to phase 1. Phase 1 means the valve 1 and 4 only connected here. So valve 1 and 4 you will give the inverter action. 1 dash 4 dash diodes will give the rectifier action. Similarly for phase B and phase T, the turn off devices along with the switches, that diodes you can expect from some positive peak will get through diodes and the negative values will get through turn off devices. So these are the due to inverter action, these are the rectifier action. These are the some currents representation. So simple example for the current source converter. Here the current is, you can clearly observe that in this current is one direction, but voltage is capable to transfer from positive voltage and negative voltage. The power reversal will be happened here through voltage reversal. So this is a basic concept of the current source converter. You always learn from power electronics also. Okay, so these are the key differences between the voltage source converter and current source converter. So the voltage source converter input voltage maintained constant and input current may or may not be constant. Some current source converter is input current is constant. The voltage is may or may not be constant. This is the major difference, first point consideration. And coming to the voltage source converters, the amplitude of the output voltage does not depend on the load. However, amplitude and the waveform of output current depends upon the load. In current source converter, the amplitude of the voltage current is independent of load. However, the amplitude and the waveform of the output voltage depends upon load. So these are the differences between voltage source converters and current source converter. You come to the misfiring of switch devices may cause the short circuit across the source and create a serious problem in voltage source converters. But coming to the current source converters, it misfiring of switch device, it's not a big serious issue in the current source converter. The peak current of the power device depends upon the circuit condition and may not be limited in the voltage source converter. Coming to the current source converters, in input current is measured in a constant current of the power device is limited. So like that, the differences is there. No need of any reactive series with the source. To obtain the constant current, a large is required in series with the source. And voltage source converter losses are less compared to the current source converter, and current source converter having more losses compared to the voltage source converters. So these are the some fundamental differences. So in this module 2 we are covered the actually the basic fundamental building block of any fact controllers is nothing but a voltage uh, converters. The converters is basically two types, that is voltage source converters and current source converters. In this voltage source converters we are discussed in the module 2 is single phase full wave bridge converter and three phase full wave bridge converter, and the basic differences between this voltage source converters and current source converters. Thank you.